The universe is a vast, dark ocean, dotted with islands of light, galaxies. Our sun, nestled in the Milky Way, holds its planets close. For ages, we believed everything in the night sky belonged to our solar family. But the cosmos loves surprises. Imagine a traveler from a distant star system suddenly appearing in our neighborhood. This is the story of 3I Atlas, a messenger from beyond, carrying secrets from a place we've never seen. It arrived quietly, first spotted as a faint smudge of light. Astronomers catalogued it, thinking it was just another comet. But its path was a hyperbola, not the gentle ellipse of local comets. This was no solar system native. It was a tourist, just passing through. The realization electrified the scientific community. A guest from another star. The name 3I Atlas tells its own story. I for Interstellar, only the third such object ever confirmed. And Atlas for the Hawaiian telescope that discovered it. Atlas scans the skies for threats, but sometimes finds wonders. This comet wasn't a threat. It was a gift. A chance to study a piece of another solar system up close. Our cosmic backyard suddenly felt much larger, more connected. Discovering objects like 3I Atlas is like finding a message in a bottle from across the universe. We can't know the sender or the distant shore it came from. But we can study the bottle, analyze the message inside. In doing so, we learn something profound about the universe we share. 3I Atlas is that message, and astronomers everywhere are eager to decipher it. Its arrival reminds us, the universe is full of stories waiting to be told. And sometimes, those stories come to us. What makes 3I Atlas so special? To understand, let's look at its predecessors. The first interstellar visitor, Oumuamua, was a puzzling, tumbling object, more asteroid than comet. The second, 2I Borisov, looked and acted like a familiar comet, with a clear coma and tail. Then came 3I Atlas. At first, it seemed like another Borisov, a classic comet, just from a different address. It had a fuzzy coma and a hyperbolic trajectory, proof of its interstellar origins. But this visitor had a surprise. It refused to fit the mold. 3I Atlas was a wild card. It began to brighten, dramatically, unexpectedly, becoming hundreds of times more luminous than predicted. This wasn't the steady outgassing of a typical comet. This was a flare, a sudden, violent outburst. It was as if the comet decided to put on a spectacular light show for its brief visit. This behavior set 3I Atlas apart from its predecessors. It forces us to ask, are comets from other star systems fundamentally different? Do they have unique compositions or histories? Perhaps its home star was unlike our sun, or its journey through interstellar space changed it. 3I Atlas isn't just another data point, it's a cosmic anomaly. It challenges our assumptions and expands our understanding. This messenger speaks in light and dust, and we're just beginning to learn its language. Each new interstellar visitor rewrites what we know, and 3I Atlas is the boldest chapter yet. Imagine watching a distant candle, expecting a gentle flicker. Then it erupts like a firework. That's what astronomers saw with 3I Atlas. As it neared the sun, its brightness climbed, as expected. But then, in late 2025, its brightness surged. Suddenly, dramatically. Observatories worldwide scrambled to capture the event. The comet, once faint, became visible to amateur telescopes, an overnight celestial celebrity. Outbursts aren't unheard of in comets, but the scale and context here were unprecedented. What could cause such a violent eruption? The energy required was immense, suggesting a major event within the comet's nucleus. It wasn't just surface ice sublimating. Something deeper was at play. Perhaps a pocket of volatile material, buried for eons, was suddenly exposed to sunlight. The result, an explosive release of gas and dust, causing the dramatic brightening. The scientific mission shifted, from simple characterization to understanding the flare itself. The flare offered a fleeting window into the comet's ancient hidden materials. For a brief moment, we glimpsed the heart of a traveler from another star. To understand the flare, we must first understand comets. Think of a comet as a dirty snowball, ice, dust, and rock from a star system's birth. Most of its life is spent frozen in deep space. As it nears a star, radiation heats its surface. Ices sublimate, turning directly from solid to gas. carrying dust with them. This forms a glowing coma, sometimes stretching hundreds of thousands of kilometers. Sunlight reflects off this cloud, making the comet visible from Earth. The solar wind pushes material away, forming iconic tails. Normally, a comet brightens steadily as it approaches the sun. But 3I Atlas's flare was too fast, too intense, a runaway process. One theory, a pocket of supervolatile ices, like carbon monoxide or nitrogen, was suddenly exposed. These ices sublimate explosively at low temperatures. A landslide or fracture could have triggered the outburst. Comets are fragile, porous bodies. Thermal stress can crack them open. A large fracture could expose fresh ice, causing a massive outburst. The flare of 3I Atlas was a dramatic reminder of how dynamic and unpredictable comets can be. When something this unusual happens, scientists propose competing theories. The leading idea, the amorphous ice hypothesis. In interstellar space, water can freeze into a disordered, unstable form. When heated, it rapidly transforms, releasing energy and triggering explosive sublimation of other ices. Another theory, the fragmenting nucleus. 3I Atlas may have been a loosely bound rubble pile or binary comet. Approaching the sun, it could have broken apart, exposing fresh ice and causing a surge in brightness. Telescopes are searching for fragments trailing the main nucleus. A third, more exotic theory, a unique chemical reaction inside the comet, triggered by solar heat. This could release energy and gas, powering the outburst. Each theory offers a different glimpse into the comet's nature. The race is on to find the evidence. When 3I Atlas flared, a global observation campaign began. Observatories worldwide, from mountaintops to space, turned their eyes to this interstellar visitor. Ground-based telescopes use spectrographs to analyze the comet's light, searching for chemical fingerprints. The Hubble Space Telescope looked for fragments and jets, testing the fragmenting nucleus theory. The James Webb Space Telescope, with its infrared vision, measured the heat and identified elusive molecules. Each instrument added a piece to the puzzle. Together, they captured a once-in-a-lifetime event. The world watched as a cosmic mystery unfolded in real time. The light from 3I Atlas was a scientific windfall. The flare blasted ancient material from deep inside the nucleus into view, a pristine sample from another star system. Spectroscopy revealed an unusually high ratio of carbon monoxide to water, suggesting the comet formed in a much colder region than our own. Astronomers searched for complex organic compounds, the building blocks of life. If familiar amino acids are found, it could hint at universal chemistry for life. Isotopic ratios, like deuterium to hydrogen, offer clues about the comet's birthplace. If these ratios differ from our solar system, it suggests great diversity in planetary formation. If they're similar, it hints at common origins across the galaxy. Every discovery adds a line to our cosmic cookbook, but interstellar objects like 3I Atlas force us to rewrite entire chapters. For years, we assumed other star systems were like ours. 3I Atlas, with its unique chemistry and behavior, challenges that assumption. Its high carbon monoxide content suggests a different snowline and planetary architecture. The existence of interstellar comets means planetary systems are messy, ejecting material into the galaxy. These wanderers could transport materials between stars, a cosmic exchange program. The flare itself confirms energetic processes we'd only theorized about. It gives us new physics to include in our models of comet evolution. 3I Atlas expands our understanding of how worlds are built and connected. The flare of 3I Atlas has faded, and the comet is heading back into interstellar space. Our chance to study it up close is over, but its legacy is just beginning. The data collected will fuel research for years. This single object has generated a mountain of new questions. Future telescopes like the Vera C. Rubin Observatory will find more interstellar visitors. We'll study a whole population, building a true picture of the galaxy's wandering comets. 3I Atlas reminds us, our solar system is part of a vast, interconnected galactic ecosystem. Each visitor is a clue to how stars and planets form, and whether life's ingredients are common. 3I Atlas arrived as a mystery, and leaves us with even deeper questions. In science, that's the greatest gift of all.